Heta is a human-writable language for creating QSP models. Hello, my name is Evgeny. Today we are talking about the Heta syntax. First of all, we'll see what data types can we use inside Heta and how to write them. So the data can be one of the following types. The simplest one is the Boolean type. This type can have two values, true or false. The second one is the number type. You can write here numerical values in the double numeric format, like here. The third one is the string type. This is just any string, words, sentences and everything you want. The blank spaces at the beginning and at the end of string are ignored. You can clarify the beginning and the end of a string using quotes. This is helpful when you want to use a number as a string or true as a string or use a comma inside the string. The next type is the dictionary. Braces clarify the beginning and the end of a dictionary. Dictionary is a set of k-value pairs that are separated with commas. The colon separates a k and a value. The dictionary type allows us to create nested complex structures. This means that value can be of any other types including the dictionary. And the last type is the array, designated with brackets. The array is approximately the same as the dictionary, but it uses the numbering of elements instead of string case. The elements of array are Boolean, strings, and other types. This type can be used for creating complex data too. If you know JSON format, you must find that Heta data structures is very similar. Later, we will see more examples of data structures. In the previous lesson, we saw the example of Heta code describing a simple system. Now, we are formulating some rules and considering code structure in more detail. First of all, the Heta code is a sequence of statements. The parsing and interpretation of the code result in creating a modern platform object. We should keep in mind that Heta is not a static language. It describes the process of a platform creation, but not the final content directly. Today, we are considering two of the statements that are used most often. The first one is a comment statement. Comments are not compiled, they decorate the code and help the developer. Heta uses // and /* syntax for single-line and multi-line comments. The same syntax is used in C or JavaScript or some other programming languages. The next and more important statement is the action, which can update a platform path or do something with the whole platform. Each base statement is followed by a semicolon. This is required for clarification on where the statement ends and where the next one starts. Now, I will describe one action statement step by step in the most general format. The plain format of the action statement is just a dictionary. We remember that we must use braces to write a dictionary. Don't forget about the semicolon. The dictionary must include the action key and the name of the action as a value. Here we're using the insert action. In general, the action property is a command, like a function in other languages. Insert means we want to create the new component of a platform. Each action has a list of required and optional properties. We can find a list of all properties associated with a particular action on the Heta homepage. Go to a browser and follow the link heta-lang github.io. Then go to the specification section and find the actions page. For example, insert requires ID and class properties. The description of classes can also be found on the classes page. Now, I want to create species with the name A0. Creating a class requires another properties. One of them is the required property compartment. Another one is optional. is amount true? This means that I want to use a zero in the amount term, but not as concentration. I can also write here supplementary information. I want to set the tag property which in array of strings A, B, C. I also want to set the initial value of the amount. I can do it in the following manner. As I have said, spaces and line breaks do not play a role in many cases. We can arrange this long statement into multiple lines and use indentations for better readability. As you can see, there are all data types that we discussed before: string, boolean, nested dictionary, number, and array. And now let's look through an example. I suggest the following model. This model presents the one compartment PK model with single bolus DOS administered at 0 time. There are many ways to write a modeling system using the Heta code. We will start from the plain Heta code, which describes the scheme. But then we will see how to make the code prettier using the shortening rules. Maybe now it looks complicated, but on the other hand, it allows us to understand better how it works. Here we see several insert actions. It means that we are creating components. Each insert action has the required class option, which describes the type of a component. There are compartments, species, reactions, and constants. Each of them has a set of class-associated properties, for example, compartment for species or actors property of reaction. Actors describe the reaction expression. Another set of properties describe numerical assignments. This is a specific property which is a dictionary. The keys show when the assignment runs. The values describe the number or mathematical expression to calculate. Start with an underscore at the end means that the assignment will run at the initial step. ODE with an underscore means that the assignment will be repeated at each time point. This is a rule type of assignment. The numerical value of a constant is described by a number in num property. The export is described by another action. Let's check if the syntax and the structure of the model are right. I'm opening the console. The name of our file is index.heta. This is the default name, so we can just type heta build. So no errors, and the compiler has created a SBML file. You can see here species, reactions, and other parts of the platform, but in another format. The created platform can be also exported to other formats: MATLAB, DBSolve, and other ones. The structure of the code is pretty clear: creating compartment, species, and then export. But it would not be fine if we had to write always in plain format. To make the code shorter and more readable, we can use the shortened version. The shortened version exists for frequently used properties: action, class, assignment. Let's take a look at how to shorten the action property. To do so, we should write the hash sign out of the main dictionary and write the action name after it, like this. It doesn't matter if you write it before or after the dictionary. I'm going to do it for all actions. So, the next property is class. We will use here add sign. Again, out of the dictionary I'm writing add, then the class name, The ID property sets the unique identifier of a component. We can write it in the shortened form without any additional symbols. The next step is to shorten the assignments. The num property can be replaced by the equal sign with or without space. The initial assignment can be rewritten by dot equal combination. For the rule assignment, we should use colon equal combination. As you can see, the code is becoming shorter and nicer. There are some actions that do not have the dictionary part at all, like here and here. If you look at the code, you will see that there are a lot of insert actions. The good news is that you can skip this action because it's default one when you set class property. I'm removing all evident insert from the code. This is the same model that we saw in the beginning, but looks better and easier to read and write. Let's check it using the builder. Again, write Heta build and enter. So, we've got the same SBML, but created with shorter code. That's all for today. Follow the Heta project site and subscribe to our channel. Thank you. Goodbye.